Assalamu alaikum. In last lecture, we discussed the first law of thermodynamic, and we will review this law of the first law of thermodynamic. حكينا إنه the first law of thermodynamic, the statement of energy conservation of thermodynamic system. عبارة عن ال heat and work are forms of energy. هي شكل من أشكال الطاقة transfer and energy is conserved. So delta U equal Q plus work on. This case, delta U is change in total internal energy, and Q is heat added to system, and work on is work done on the system. This is state function and this is path function. Or delta U equal Q minus work by done by the system. Okay, the internal energy of the system tends to increase if energy is added via heat, Q, and decrease via work done by the system. So we have done by the system is negative. So it will be the internal energy, it will be decrease. So the sign on Q and work depend on the way the internal energy is changed. So if Q and W are positive, the internal energy increase. But if Q and if heat and the work are negative, the internal energy decreases. And the work in thermodynamic process, as we uh, talked before, as state previously, pressure, temperature, and volume are considered state variables. إذا هي عبارة عن variables and are used to define the particular state of the system. وهي تستخدم لتعريف الحالة الخاصة للنظام. So work and heat are called transverse variables. These describe change in its state. إذا تغير الحالة السيستم. So they don't describe the state. We know how to describe the work done on the system. For example, let us look at applying force to piston in order to compress the gas inside container. So we have this force compressed, then we have delta Y, and we have the area of the piston. So also we have the delta V, the volume of the gas. احنا بنعرف ان الورك تساوي الفورس minus force مضروبة في delta Y, and we have the pressure, the force على الاريا, and the force in this case equal the pressure مضروب في الاريا. So if we substitute the force in the equation of the work, then the work equal minus B في A في delta Y. لكن الاريا مضروبة في delta Y هي عبارة عن delta V. So delta V equal A في delta Y. In this case, the work equal minus B في delta V. Okay, this is during a compression. When we compress the gas, work done on gas is positive. A quasi-static process. Work is a transfer of energy that take place when an object is moved against an opposite force. So if the gas is compressed slowly, then this is the gas, okay, and this is the piston, and this is the area of the piston. So if the gas is compressed slowly enough for all of the system to remain in thermal equilibrium, external force is equal and opposite to force gas exert on piston. In this case, work done on gas. So minus F is parallel to Y. This is F and this is Y. In this case, dW equal F mod dot ds as a vector. إذن dW equal minus F dy وتساوي minus B في الاريا في dy وتساوي minus B dV. If we make integral to both sides, d للwork equal the work, and we make integration from V initial to V final B dV. This is the total work done to change the volume of the gas. Okay. And then the work done by external force to compress gas enclosed with a cylinder fitted with piston. Then this is within a cylinder. This is the piston, and here the area is the piston, and this is delta x. So the work equal pressure في الاريا في dx, and the pressure في الاريا it's the force وتساوي البريشر في A في الاريا البستون في dx وتساوي minus B dV. So the sign if the volume is decreased, work is positive by compressing gas. We increase its internal energy. إذا بهاي الحالة راح تزيد internal energy. If the volume is increased, W is negative. The gas decreases its internal energy by doing some work of the environment. So work dE في dV applies to any shape of the boundary. So we can apply to any shape of system boundary على حدود السيستم. إذن the work from path from 1 to 2 equal the integral minus integral from V1 to V2 لB dV. إذن du equal Q minus B dV. Here a dV and this is a du. Okay. Work done by an expand gas. If we expand gas, okay, in this case, what's happened? Gas expands slowly. Here is the gas, the piston, this is the area, and this is the gas, and we have to expand. Okay, we have expand slowly enough to maintain thermodynamic equilibrium. So تغير بالحجم الwork تساوي integral P dV from V initial to V final. Positive dV. This means positive work. Work is done by the gas. هذا يعني إنه الانرجي leaves the system and goes to the environment. أما إذا كان minus dV negative work is done on the gas. هذا يعني إن energy enters the system from the environment. إذا الإنرجي إذا كان عندي نيجاتيف معناته الإنرجي بتدخل على السيستم من وين؟ من المحيط. أما إذا كانت بوزيتيف فالإنرجي بتترك السيستم and goes to environment. So dW equal F dy, and this again pressure في الاريا في dy, area في dy equal volume. This is an increase in volume dV, and dWbdV, this is the total work done to change the volume gas from V initial to V final. Okay. This is a PV diagram showing several isotherms. So we have the pressure and we have the volume. If we go to this blue, it's constant. Then the pressure is constant. In this case, the process is isobaric process because the pressure is constant. أما إذا كان عندي isovolumetric process, this means the volume is constant. Then this at this point, this is the volume is constant. Then in this curve, isovolumetric process. And we have from pressure goes slowly down. This is a diabatic process. And the red one is isothermal process. And in isotherms, this like this one process, this called isotherms. What type of a process described by each of the arrows? We already describes all the process. PV diagram again, pressure with volume. Okay, so a PV diagram is a plot of pressure versus volume. إذا احنا بنرسم البريشر مع مين؟ مع الفوليوم. The work done during the process shown by the PV diagram can be determined by looking at the area under the curve. Either this is the area under the curve. This is the process from initial to final. And the work is the area under the curve. Remember, this is the same as the integer expression for the work. The work equal PdV from V initial to V final. Okay, example in three figures A. This is A, this is B, this is C. Rank amount of work done by each the process shown from largest to smallest. How much work is done in each case. احنا بنعرف انه الwork is the area under curve. إذا area under the curve. So if we look to B is greater from C, greater from A. Okay. A equal the work equal minus B initial V final minus V initial, and B equal minus B final minus B B final. Okay, B final مضروب في V final minus V initial. This is V final to V initial. And see, in this case, we can take the integral, the work, minus BV dV from V initial to V final. Okay, the amount of work done during the process depends on the path you take from your initial point to your final point. إذن هي تعتمد على الباث from initial to final. In other words, it depends on how you change your pressure and volume. Okay. إذا قد إيه بنغير الفوليوم and also كم بتغير البريشر. If we shade it as the work done by the system, this is the process from initial to final. In this case, the work is greater than zero. And this is pressure with volume. And this is from initial to final state. Then in this case also the work greater than zero. And here is from initial to V to final, also the work greater than zero. And here we can take the path from this point, from initial, this path to final, or we can choose the other path from initial to final state. Then there are many ways to take the system from initial to final. The work done on a Q depends on the path. And here also, in this case, you can see from final to initial. In this case, the work is less than zero, so it's negative. And here it's like hysteresis curve from initial to final, or from final to initial, the work net, it will be greater than zero. Okay. Then the work and heat are not state functions. We can bring the system from state 1 to state 1, from state 1 to state 2 along infinite number of paths. إذا ممكن نروح من هون، ممكن نروح بهاي الطريقة. So, and for each path, pressure as a function of temperature volume will be difference. Then it work from 1 to 2 equal minus integral from V1 to V2, the pressure as a function of T and the volume dV. So since the work done on the system depends not only the initial and final state, but also in the intermediate state. It is not a state as a function. So delta U equal Q plus the work. U is a state function, work is not. Q is not a state function either, but U is a state of function. So the work is negative for the clockwise. إذا رحنا راح يكون نيجاتيف إذا كنا باتجاه عقارب الساعة. Okay, like this. And if the cycle process were carried out in the reverse order, إذا أخذنا بالعكس, okay, counterclockwise, the network done on the gas would be positive. So this is the PV diagram from the A, and here is the system. We take the path from A, B to C, and C to D, and D to A. And we have B1, B2, and this is V1, and this is V2. So the work net, we have the work from A to B, and the work from B to C, and the work from C to D, and the work from D to A. But the work from B to C is zero because depends on the volume, and the volume in this case is constant. So the delta V equals zero. Also, the work from D to A is zero because the volume is constant. So delta V equals zero. Even work net only, we have the work from A to B, زائد the work from C to D وتساوي minus B2 في V2 minus V1 minus B1 في V1 minus V2 وتساوي minus B2 minus B1 مضروبة في V2 minus V1 and this is it will be less than 0. Okay, work from closed cycle. If we have closed cycle, consider A, B, from A to B to A. So we have this is the work from A to B, and this is the work from B to A. And consider A, B to A. Also, the work A, B, A equal the area. And if we have reverse cycle, make it counterclockwise. So this is work AB and this is work minus work BA, the reverse process. So process and cycle. Process and cycle change of state implies one or more properties of the system has changed. How these properties would change outside of time is curiously outside the frame of work of equilibrium thermodynamic. So the best way to think of them is that the change are slow relative to the underlying molecular time scales. إذا لازم A إنه نفكر إيش are slow relative to underlying molecular time scale. And we have the succession of change of state. This is the process, assuming a process are all sufficiently slow such that each stage of the process is near equilibrium. So certain amount common process are isos meaning equal. عندنا الadiabatic no heat transferred, isothermal constant temperature, isobaric constant pressure, and isochoric or isovolumetric state is constant volume. So we have to know these process, definition of these process, and an important notation in thermodynamic is that of a cycle. What is the cycle? Cycle is a series of a process which return to the original state. So we start from initial state and we back again to the original state. إذا هي عبارة لكن between الانيشال والفاينل state أو البداية we have a process series من the process which return to the original state. The cycle is thermodynamic is اللي هي round trip. Then path of the PV diagram. So we have adiabatic, we have isochoric, this our isovolumetric, the volume is constant, and in this case, if the volume is constant, the work is zero, and isothermal, and isobaric, the pressure is constant, so the work equal B for dV. And the example of the piston. This is examples for ideal gas. From process 1, we have 2 isovolumetric, 4 is isobaric constant pressure, and 1 3 isothermic. رقم 1 اللي هي adiabatic process, and also we have رقم 3 1 و3 واحد وثلاث is isothermic. Okay, I will end this lecture at this point, and next lecture we will explain and discuss these process according to the ideal gas law. So thank you for your attention.